All right, in this lesson we're going to talk about acceleration. So acceleration is the rate at which an object changes its velocity. An object is accelerating if it's changing its velocity. So you can be going from 10 meters per second to 20 meters per second. Okay, there's a change in velocity there. Another way you can change your velocity is by changing your direction. So if you're going north and then all of a sudden you're going east, your velocity's changed because remember, velocity has a direction. So not only is your speed changing, but also your direction. The units that we use for acceleration are meters per second squared. Okay, and an example would be 10 meters per second squared. Okay, positive acceleration is acceleration in the same direction as the velocity, so that would be speeding up in a car. Negative acceleration is acceleration in the opposite direction as the velocity, so slowing down in a car. We find average acceleration by taking the change in velocity and dividing it by the time in which the change occurred. So here's an example. It says, use the equation for acceleration to determine the acceleration for the following two motions. All right, so let's start by looking at the first table here. So on the first table here, you notice that we start with a velocity of 0 meters per second, and then it goes to 2 meters per second. So that's a change of 2. There's a change here going from 2 to 4. That's a change of 2 meters per second. Here, it's 2 meters per second. Here, it's 2 meters per second. So every second, we're adding 2 meters per second. So for practice A, the acceleration will be 2 meters per second, and that's how the acceleration is changing per second. So our units are going to be meters per second squared. In the second example here, we go from 8 to 6. That's a change of minus 2. From 6 to 4, same thing, minus 2. 4 to 2, minus 2. 2 to 0, minus 2. So our acceleration here is minus 2 meters per second squared. All right, if you recall, we have position versus time graphs. On our x-axis, we have time. The units are going to be in seconds, minutes, hours, etc. On our y-axis, we have position. So that's going to be a distance in meters, centimeters, miles, kilometers. And then, of course, we're going to have a slope on our graph. That slope is our average velocity. All right, so here's an example. We're going to create a graph of constant velocity here. Let's throw a couple points on the graph. So at time of 0, our position is 0. So we'll just put an X there. At 1 second, we're at 10 meters. So let's put an X there. At 2 seconds, we're at 20 meters. So we're here. 3 seconds, 30 meters, right about here. 4 seconds, 40 meters, right about here. 5 seconds, 50 meters, we're right about here. So if we connect the dots, we get a trend line like that. So that is constant velocity. So our velocity is the same every single second. We're always moving at a velocity of 10 meters per second. I know it's 10 meters per second because if I look between each interval here, it changes the distance by 10 meters. Okay, if I were to take the slope here, rise over run, 10 over 1, our slope here would be 10 over 1, or just 10. In this example, we have something different going on. So we'll have constant velocity, but then we're going to stop. So let's go ahead and draw these points out. So 0, 0, right there. 1 second, 5 meters is right here. 2 seconds, 10 meters is right here. 3 seconds, 15 meters. 4 seconds, 20 meters. Okay. And then from 5 to 10 seconds, we're at 25 meters. So here to here. So let's connect the dots here. And then there we go. Okay, so here on this part of our graph, we have a slope of 5. So every second, our distance is changing by 5. So we go from 5 to 10 to 15 and so forth. Here, where it's flat, our slope is 0. We're not changing position. We're sitting still. So that's constant velocity. Stopping. Stopping is another term for constant velocity. Constant velocity is the same thing here because we're not changing. We're still at the same velocity, which is 0. So let's look at an example of acceleration. Okay, so here's a graph of acceleration. Let's go ahead and plot some points here. All right, so we've got 0, 0, which is right here. At 1 second, we're at about 2 meters, which is maybe, this is a little tricky to draw. Let's put it right about there. 2 seconds, we're at 8, which is like here. 3 seconds, we're at 18, which is like here. 4 seconds, we're at 32, which is right about here. And then 5 seconds, we're at 50. So our graph isn't going to be a straight line here. Instead, it's going to curve up like this. Okay, so our slope is changing. Okay, so like our slope is different between and on A, between the two dots on A, the slope is a lot different than it is here. Our slope is a lot different than it is here at B. Okay, you can tell that this is a lot flatter than it is here. So when we're accelerating, we're changing our velocity. Our slope's going to be different. So you'll end up with a curve on a graph anywhere you have acceleration.